Decoding the Disciplines it started out as a program for faculty who were teaching large classes. And at first we didn't really know what we were doing. We just wanted to help people who were teaching large classes. And over time, it developed into a model for helping people get through stuck places. The stuck places, which we called bottlenecks, and it has now grown into a theory of pedagogy. And what we have found is that the places where students get stuck turn out to be like a red flag of where we aren't showing the students what we do. That's the special kind of thinking in our field. It may be that we can do something as an expert in our field that's very complicated, and we haven't broken down that complicated thinking for the students. So they show us those things that we're not teaching them at the bottleneck. And then Decoding the Disciplines, besides showing you, the bottleneck shows you where the stuck place is, then the rest of the theory shows you how to do basically a task analysis of how to unpack the expert's expertise. And then the rest of it shows you how to model that thinking for students, how to help them get practice with those crucial operations, what motivation considerations you should take into account, and how you're going to have the students, to what extent have they gotten these crucial operations and where haven't they gotten it, so I can sort of get this feedback system going where I can help them get it better and better. And eventually, then we found even that the seventh step of sharing becomes very important because people will collect data, analyze it, and when you do that step of sharing it with other people, you actually get insights yourself. So it's not a linear thing anymore. Now, it turns out as a theory of pedagogy that because there's 10,000 teaching techniques out there in the field of educational development, when somebody, say, wants help with how to lecture, you can just take the part that talks about how to show people how to model, and there's principles about how to model that this theory helps us know what to tell people about. So it's gone from a practical solving a problem to a theory of pedagogy that really guides all of the work that we do.
So threshold concept is a notion that was formulated by Ray Land and Jan Meyer at the time they were both in England. And it's the idea that disciplines have, not at their core, but sort of at their perimeter, some very complex ideas that can be difficult for somebody new to the discipline, but once they're grasped, they really open up a new way of seeing that discipline. So they don't just embody content knowledge, but they embody ways of thinking that are particular to that discipline. So once working with a faculty member here in photography, he was worried that his students weren't really getting how he judged their work. Right? They didn't really think that he had a right to make judgments of their work. And I said to him finally, have you ever shared with them the idea that art is about solving problems? That art is solving problems? He says, well, no, I didn't think I'd need to. That was something that was such a basic level thing for him, but the students weren't understanding. So it can be just that simple, but once it's understood that way, you cross a threshold. That's why it's called a threshold concept.
To my mind, the trend or idea that's emerging that is being most useful to people it really comes out of two different projects. One is the notion of threshold concepts, the idea that students' difficulties in learning might be tied to the nature of the discipline and to the difference between how experts think and how people who are beginning think. And some of that is a really, really old idea. I mean, that was the idea that framed a lot of my research when I first encountered, John Bransford's How People Learn. So it's not really a new thing. But the language of threshold concepts, paired with the methodology of decoding the disciplines that's come out of the work of people in Indiana as a way of working through that process, that seems to me to be a set of models, both theoretical and practical, procedural, if you will, that has been really productive and I think is moving us in new ways.
In every field, there are really unique ways of thinking. So in art, you might have to have a special way of thinking in art might be that you take an idea over here, an idea over here, and an idea up here, and you bring them together in a new way. And you have to really show people something. And then, say, in chemistry, you want to, maybe you're a nanochemist, and you want to look at the tiniest things that exist. I don't even know what you call them, smaller than an atom. And you want to look at it, and you want to be able to see how they're operating, and you have to look at them. So one is a really small analysis, and another is some kind of big synthesis. But both of those kinds of thinking do have some kind of visual aspect to it. So there's parts of the thinking that will be similar. But the meta part, where you teach students that in art we're going to take ideas and bring them together, and that's some of the big meta thinking in art. But we're also doing visualization. But in chemistry, we're doing some visualization, but we're really systematically taking things apart. When students can know those are the moves that we do in the field, they can see the parts that are similar. I'm going to do some similar things in art and chemistry, but I'm going to do some very different things. And students will kind of know. Otherwise, students tend to go to a chemistry course, they try to study the same way, and they might even in an art course, tell me what to do. And art teachers hate to have somebody. All the teachers hate when students say, just tell me what to do. But they don't know what the different kinds of thinking moves are.